Hi, this is Mr. Shumway. A video clip to explain momentum and a few other terms. A person that has a mass of 50 kilograms moving at 10 meters per second has a momentum of 500 kilogram meters per second. So what you do is you just multiply the mass times the velocity. So 500 or 50 times 10 gives us the 500 kilogram meters per second. So a football player that's heavier has more momentum, or a football player that's running faster has more momentum. So there's two ways to increase momentum in football. So work is a term that we need to define. It's equal to force times distance. So lifting 1 kilogram 1 meter high, how much work is this? Well, nowhere in that equation or in that information is there anything about force. But we learned earlier that force is equal to the mass times the acceleration. Well, when you're lifting something, you are doing work against gravity. So the acceleration that we're talking about is the gravitational, is the acceleration due to gravity. So in this case, we'll say that the force is equal to the 1 kilogram times the acceleration of gravity, which is the 10 meters per second every second. So the force would be 10 newtons. And if I lift that 1 meter high, then I will have done 10 times 1 would be 10 joules of work. So the force is 10 and the distance is 1 meter, and that equals 10 joules. Well, if I drop a mass, say it's 1 kilogram, it can do 10 joules of work because it took me 10 joules of work to lift it. So if I drop it, it can give that work to do something like drive a spike into a railroad. So objects that have the potential to fall have what we call potential energy. In this case, once the mass has hit the ground or the railroad spike, it has no more potential to fall. It's fallen as far as it's going to, and it has given up all of its potential energy. So let's figure out the equation for potential energy. So it'd be the mass times gravity, that's the force, times the distance, that's the height. So the work that we do to lift something, excuse me, to lift something is the same as the work that could be done, the potential that it has to do work. Work is force times distance. So the potential energy that we give something by doing work on it is the mass times gravity times height. We call that the potential energy, and that little g has to do with gravity. It's gravity that gives it that potential to do work, because gravity is going to pull it down. It's going to accelerate it. Well, what if something rolls down the side of a skate park bowl? When it's at the bottom, it has no more potential energy. It can't fall any further. But it hasn't stopped, so until something stops, it still has energy. So what should we call this energy? It's converted all of its potential to fall, all of its potential energy, to a form that we call kinetic energy. Kinetic having to do with movement. And there's an equation, that little k stands for kinetic, that has to do with its velocity and its mass. Its kinetic energy is equal to 1/2 its mass times its velocity squared. Only the velocity is squared. So let's go through these things that we've learned. We learned about momentum. So a 75 kilogram person running at 2 meters per second has a momentum of 150. kilogram meters per second. I just multiply the mass times the velocity. Potential energy is mass times gravity times height. So the mass has 1, 2, 3, 4, 5 places. The height has 2 places, so that would be 7. And I multiply that by gravity, which is 10, the potential, the acceleration due to gravity. So there's 5, 6, 7, 8 decimal places, so it's 1 times 10 to the 8th potential energy. Energy is in form of, has units of joules. So 1 times 10 to the 8th joules. Now you can see how dams that back up water and lift water have a great potential to create electricity because there's a lot of energy stored in that water that can fall. So the work to lift a 50 kilogram person 2 meters, well, we need to remember we have the mgh is the potential energy. We have to provide all of that potential energy, so we have to do that work. So we have the 50 kilograms, we have the 10 for the potential energy of, the acceleration due to gravity, gravitational acceleration, and the height would be 2. So 2 times 50 would be 100, times 10 would be 1,000 joules. That's how much work we have to do to lift a 50 kilogram person 2 meters high. So let's say a biker goes into a slick rock fish, like up in Moab, that is 2.5 meters deep. So how fast will he be going at the bottom if he doesn't use his brakes? Well, his potential energy is his mass times the gravitational acceleration times the height. And I'm going to convert, we think all that energy is going to be converted to kinetic energy, which is 1/2 the mass times the velocity squared. We wanted to solve for his velocity, so we want to get the v all by itself. So I'm going to divide by m. Interesting, mass doesn't even matter. So then I'm going to multiply by 2 on each side. So 2gh equals v squared. And then if I take the square root of each side, then I have the square root of 2gh is equal to the velocity. Well, in this particular case, it's the square root of 2 times 10 meters per second every second, and we are 2.5 meters high. 2 times 2.5 is 5, times 10 is 50, square root of 50. Well, that's pretty close to 7. Square root of 49 is 7. So he's going to be going about 7 meters per second. You can do that on your calculator to get a little closer. Take the square root of 50. So basically a little review. The momentum equals the mass times the velocity. Potential energy for gravity would be mass times gravity times height. So either the potential to do work or the work that we would have to do to raise something that high. And kinetic energy, 1/2 mv squared. Those ones we'll want to memorize.